Have you ever just stared at a huge number, like the population of a city or the price of a car, and just felt a little lost? Well, today we're going to crack that code. We are going to build a simple toolkit with two super powerful techniques that'll let you master any number you come across, making them simple and crystal clear. So, if you've ever wished you could just shrink a long, complicated number down to size, then you are definitely in the right place. We're about to unlock a couple of awesome techniques that'll help you do exactly that, turning these intimidating numbers into something you can actually manage. All right, our very first tool is called partitioning. And honestly, the best way to think about it is like looking at a number's DNA. We're going to break it all the way down into its basic parts to see what it's really made of. And that's going to give us the key to understanding its true value. So here's the key thing to get. Partitioning is all about understanding that a digit's value depends completely on its place. It's not just a random string of digits. It's a whole system where location is everything. This is what we call place value, and it's the secret sauce for seeing how numbers are actually built. Okay, check this out. Take the number 4,582. When we partition it, we can see the 4 isn't just a 4, it's 4,000. The 5 is really 500, the 8 is 80, and the 2 is just 2. See? Each digit has its own specific job, and partitioning shows us exactly what that job is.
And what's really cool is that the exact same logic works perfectly for decimals. With 63.745, we break it into 60 plus 3. But then, after that decimal point, the 7 becomes 7/10ths, the 4 is 4/100ths, and the 5 is 5/1000ths. It's the same principle, just on a much smaller scale.
And this chart right here, this is our master guide. It's like a map for numbers. It shows us exactly where each digit lives and what it's worth. Every single number has a specific address on this chart. And notice how each step to the left gets 10 times bigger and each step to the right gets 10 times smaller. Understanding this map is absolutely key.
Okay, now that we know how to deconstruct numbers, let's learn how to simplify them. This is why we round, to make numbers easier to work with, right? To estimate things or just present data clearly. And our second tool, rounding, is all governed by one simple, powerful idea, the golden rule.
You're going to want to memorize this because this is everything. First, find the place value you're rounding to, the tens, the hundreds, whatever. Then, just peek at the digit directly to its right. If that neighbor is 5 or more, you raise the score. You round your digit up. But if it's 4 or less, you let it rest. It just stays the same. That's it. That's the entire rule. Simple, right?
All right, enough theory. Let's put our golden rule into action and start with some whole numbers.
Let's look at 67. To round to the nearest 10, we find our place, that's the 6 in the tens place, and we look next door at the 7. Since 7 is 5 or more, we raise the score, and 67 becomes 70. Now, how about 356? To round to the nearest 100, our target is the 3, so we look at the digit next door, the 5. 5 or more, raise the score again, and 356 becomes 400. It just works every time. And the real beauty here is that this rule works no matter how big the number gets. Let's try rounding 25,460 to the nearest 10,000. We look at the 2 in the 10,000s place, and we check its neighbor, which is a 5. 5 or more, raise the score. So 25,460 rounds right up to 30,000. The rule is always the same. So, what about those decimals we were talking about? Well, you probably guessed it. The golden rule works just as perfectly on the other side of the decimal point. Let's take 6.8. To round to the nearest whole number, our target is the 6, so we look at its neighbor in the 10ths place. It's an 8, so we round up to 7. Easy. Now for 5.38, rounding to the nearest tenths. Our target is the 3, so we look over at the hundredths place. It's an 8, so that 3 gets rounded up to a 4, giving us 5.4. You see the pattern, right? And we can get even more precise. Let's round 4.236 to the nearest hundredths. We look at the thousands place. It's a 6. That's 5 or more, so we raise the score, turning 4.23 into 4.24. This is so useful because it lets us simplify numbers while still controlling exactly how precise we need to be for something like a science experiment or a financial report. Okay, you've seen the tools. Now it's time for a little pop quiz to put your new skills to the test. You ready for this?
First up, a partitioning challenge. How would you break down the number 4,506 into its parts? I'll give you a second to think. And the answer is 4,000 plus 500 plus 6. Did you notice we skipped the tens place? That's because the 0 means there's just no value there. Awesome job. Okay, next up, it's time to use that golden rule. Round 8,562 to the nearest hundred. What do you think? The answer is 8,600. We're rounding the hundreds place, so we look next door at the tens digit, which is a 6. Since that's 5 or more, we round the hundreds digit up from 5 to 6. Excellent. And for our final challenge, let's try a decimal. Round 5.674 to the nearest tenth. You've got this. And the answer is 5.7. We just look at the hundredths digit, the 7, which is 5 or more, so we round the tenths digit up from a 6 to a 7. You have totally nailed this. So what's the big takeaway here? You now have 2 essential skills to handle pretty much any number you find out in the wild. The next time you see a statistic in a news headline, a price tag at the store, or data in a report, you'll know how to break it down and see what it's made of, and how to round it to quickly understand its scale. You've learned how to make numbers work for you. So where are you going to use this new power first?